Hi, I'm Ben Canning, and this micro lecture is on distance in freefall. As always, you need 3 or more bullet points worth of notes, a 1 to 2 sentence summary, and your follow-up questions on Google Forms. All right, so in freefall, things pick up speed as they fall downwards. We've talked about that using the equation v equals u plus acceleration times time, or a times t. This means that as things fall, they fall further and further each second. So looking at a snapshot diagram, or in this case, a snapshot photo or stroboscopic photography, we can see that the distance between each snapshot is increasing as this person falls. That means they're speeding up. Now, these snapshots are probably taken at like 0.1 second intervals or something along those lines. So plugging in, if we want to calculate that distance, we'd plug into our good old familiar equation of d equals ut plus 1/2 at squared. But since we're in free fall, the acceleration is going to be 9.8 meters per second squared. So we'd plug in g for that. The distance here would come out in meters. You'd still use d for distance. Now, one thing you're going to want to pay attention to is what direction you are assuming positive is. So, for example, we are assuming here that positive is in the upward direction, which makes gravity, or g, negative 9.8. If instead we assumed positive was in the downward direction, this would be a positive 9.8. Now that'll be important when interpreting graphs because oftentimes people flip them around just to make their life easier, and you just need to pay attention. So is positive in the upward direction or the downward direction? So a few examples of what that might look like. Assuming something has an initial velocity of, an initial position or distance of 0, it would look something kind of like this. So we've got half of a parabola here because it's a quadratic formula. If instead, though, we had something that actually started with an initial distance, we would just add that out front, and that might look something like this, where it's the same graph just shifted up by 5 because that's its initial position of 5 meters. Now, if we were flipping this around and assuming assuming down is negative, then we might get a graph something like this, where it's still a parabola, but it's aimed downwards, and usually then we're having an initial height. So here, initial height of 50, gravity is in the negative direction, and so it would be accelerating downwards. If we wanted to plug this in, just so you see the pattern, if we assume that a rock is being thrown straight up with a velocity of 30 meters per second, and that up is positive, so its initial velocity is going to be positive, and that down is negative, then that means gravity is negative 10 meters per second, then we can plot distance versus time, and what we will see is that comes out to an upside down parabola. Again, this is because we've got this idea that the acceleration is downwards, but our initial velocity is upwards. So this is what the distance versus time would look like. That's it for this one. 3 or more bullet points worth of notes, a 1 to 2 sentence summary, and follow-up questions on Google Forms.